Welcome back to our channel, that is Ajay Kumar Yadav, and we are going to talk about a very fresh topic today, that is nothing but different types of different types of displacement time graph. You know very well what is displacement, and you know what is time. That is SI unit of displacement is meter and time is seconds. So we are going to talk about different types of displacement time graph. Question number 1. So in the graphical section we are going to talk about the different types, and different types will consist of different ways that we have to assign by this. So very first case we are going to talk about the graphical segment of it, that is nothing but the straight line. So in the straight line graph, this is the displacement and this is the time. So it is independent, it is dependent. This is the displacement time graph. Okay, this is x-axis, y-axis. I'll consider this is my A, I'll consider this is my B. So point number 1, displacement time graph is a straight line. Point number 1, what you are going to differ there? Displacement time graph. In the displacement time graph is a straight line. It's said to be as it is a straight line. Displacement time graph is a straight line. Point number 2 we are going to talk is it is parallel to the time axis. AB line is parallel to time axis. Okay, and the point number 3 we are going to say the slope is 0. That's why we can say that it has zero velocity. I hope you will be very clear. So with this graph we can say that point number 1, displacement time graph is a straight line. Point number 2, AB graph is parallel to time axis and slope is 0 since it has zero velocity. Next we are going to talk about the second type of the graph which we want to discuss there, and in this is also displacement time graph which is a straight line. So of course you will understand, this is my y-axis, this is my x-axis, this is my displacement, and this is my time section. Even I can consider this is my AB section. So we can say that displacement time graph is a straight line. Point number 1, displacement time graph. We have to write in words. Displacement time graph is a straight line. Displacement time graph is a straight line. Point number 1 is very clear. Next, point number 2 we are going to discuss is it is inclined to x-axis. It is inclined to x-axis. So if it is inclined to x-axis means it is a time axis. Point number 3, the slope of this graph is an single slope. It is a single slope, so we can say that slope is a single slope. We can say what is a single slope since it has only one slope there. Single slope is single. Next, point number 4 we are going to discuss there. It has nothing but it has zero acceleration with a constant velocity. So it has zero acceleration. Since it has zero acceleration with a constant velocity. Okay, so with this graph I can say displacement is y-axis, it is x-axis, displacement time is a straight line, it is inclined to x-axis, slope is a single slope, it has zero acceleration with constant velocity. I hope till here you will be very clear. And the next segment we are going to talk is point number 3, that is displacement time graph. That this is the graph for the third segment, and this graph is going to be like this. So here also you can define what is the way of behaving the graph with respect to displacement and time. It is x-axis, it is y-axis. So I can say that very first point, that is greatest displacements are making a place which is equal to the intervals of time. So greatest displacement, point number 1 which we are going to discuss is nothing but greatest displacement. If we have the greatest displacement, obviously we can say they are taken place as greatest displacement is taking place as equal intervals of time. So whatever the displacement are taken place, it is greatest with an equal change in the time. And point number 2, we can say that displacement time graph OA represents the increasing velocity. Since it is a displacement time graph, the curve O to A, since it is the origin, this is my A. So displacement time graph OA curve represent increasing velocity. So it is said to be as increasing velocity. If it is increasing velocity, then obviously it is said to be as accelerated motion. Obviously it is rated as accelerated motion. Correct only, na? Since it is increasing velocity means it is accelerated motion. So, and the third case we can say that for constant acceleration, if I say the acceleration is very constant, acceleration is constant means obviously I can say that the displacement graph is a parabola. Displacement time graph is a parabola. Displacement time graph is a parabola. Parabola means it is rising in nature, so it is increasing, that is bending upward. We can say that it is bending upward. Okay, since it is bending upward. So in this graph I can say that greatest is the displacement is taking place as equal intervals of time. Point number 2, displacement time graph OA curve represent increasing velocity, hence motion is an accelerated motion, and for the acceleration is constant, the displacement time graph is a parabola which is bending upward. It is a bending curve. So how it is bending? It is upward since it is an parabola. I hope till here you will be very clear. Same graph, you have to draw it in a different style here. That is nothing but downward direction. I hope you will be very clear. Till here you will not find any difficulty to understand. Now in this graph I can say that it is dropping like this. It is dropping like this. Here also I can represent this is the OA graph. Since it is a y-axis, it is displacement. Since it is an x-axis, it is said to be as a time. So I can variable represent here. Same things are represented there. Since I know that you can represent the same points, decreasing displacement is taking place as equal intervals of time. Decreasing displacement is taking place, so it is taking place so as equal intervals of time. It is in equal intervals of time. It is in the equal interval of time. And the second thing we can represent here, displacement time graph. We know that displacement time graph OA curve represent decreasing velocity, represent uniform decreasing velocity. Uniform decreasing velocity. What do you mean by uniform decreasing velocity? It is constantly decreasing in nature. It is constantly decreasing in nature. So it is called as decelerated motion. It is called as decelerated motion. Decreasing means decelerated motion, increasing means accelerated motion. And the third point, we can say that if the acceleration is constant, if I can say for uniform deceleration, for uniform deceleration, for uniform deceleration, for uniform deceleration, I can represent displacement type graph is a parabola. Displacement time graph is a parabola. Displacement time graph is a parabola. Sir, what do you mean by parabola here? Which is bending downward. Which is bending downward. By seeing the graph itself, you can understand it is bending downward. Though it is a parabola, it is bending downward. Okay. Next. And the next straight thing we are going to discuss here. The last remaining two more things are there. Let us discuss those two more graph there. That is nothing but, this is my next graph. So I hope you will be understanding more clear by clear, since we are going to recapitalize also at the end of this session. So this is also same like displacement section. This is my fifth section of the graph. As you can understand, this is the time segment. This is my x-axis. This is my y-axis. Here what they want to represent. Here displacement is a decreasing uniformly. Point number 1. Displacement is decreasing uniformly. Displacement is decreasing uniformly. If it is decreasing uniformly with the time, so obviously we can say that it comes back to original position. Point number 2, it comes back to 0. It comes back to 0. At a course of time, it will come back to 0. Next, point number 3. What can we expect? Point number 3, it has a negative slope. Displacement time graph has a negative slope. Displacement time graph has a negative slope. It has a negative slope. Okay. So displacement time graph is a negative slope. Next, and next but not the least point we are going to discuss, it represents uniform negative velocity. It represents uniform negative velocity. Uniform negative velocity. So these are all the points we have to discuss for this type of graph. And the last but not the least, this is the last graph we are going to discuss in our today's session. The last but not the least, this graph behavior will be like this. So we have to understand, this is the one segment of the graph. It is from A to B. A to B means what? It is in the decreasing order, but it reaches to B. B means it reaches to the 0, and beyond that it is going to travel to C. So let us see the points there. A displacement of the body becomes negative after a time t. So point number 1 we are going to discuss. Displacement of the body becomes 0 after point t. After point t. After the time t, we can say, instead the point you can understand it is a time t. And the next point we can say that it is increasing in the magnitude with the time t. After reaching to the time t, then it is increasing with the increasing in the magnitude. Increasing in the magnitude reaches to 0. Reaches to C. increasing in the magnitude, it is reaches to C. Next we are going to discuss about the point, that is, from the graph is nothing but body returning from the position A, the body returning from the position A, returning from position A, body is returning from position A and moves past the position B, moves past the position B, move past the position B and then move towards C, and then moves towards C, moves towards C. So that's all about this graphical segments of the displacement time graph. We're going to recapitalize the things again so that you can better understand the graph without any distraction. So this is the first segment of the graph. The graph is very parallel to x-axis, and here we can say that AB line is parallel to time, so that we can say slope is 0 and it has a 0 velocity. See the next graph there. This is a slanting graph. So displacement time graph is a straight line. It is inclined to x-axis. Slope is in single. So it has 0 acceleration with a constant velocity by this graph. Here the graph is attaining parabola. So point number 1, the greatest displacement is taking place in equal intervals of time. Point number 1. Second thing, displacement time curve represent increasing velocity and accelerated motion. Point number 3, the acceleration is constant. Displacement time graph is also parabola bending upward. The next point is parabola which is decrementing down. So decreasing the displacement time graph takes place in equal intervals of time. Displacement time OA curve represent uniform decreasing velocity, so decelerated motion. And for uniform deceleration, displacement time graph is a parabola which is bending downward. It is bending downward. The next segment of the graph will be like this. Let us see the behavior of this graph. The displacement is decreasing with uniformly with the time, and it comes back to 0. Obviously it comes back to 0. Displacement time graph has a negative slope. The next point is displacement time graph has a negative slope, and it represents uniform negative velocity. It represents uniform negative velocity. See, this graph also quite different from the above graph, but see what is the difference there. Displacement of the body becomes 0 after passing the time t, and then increasing in the magnitude reaches to C. So after crossing from A, starting from A, it reaches to B, that is comes back to 0, and past crossing the C. So end is touches with the C, and the body returning from position A move past the position B and then moves to an C. It is moved to an C. Hence it is said to be as with a uniform velocity. Of course you have to mention one more word, moves with the uniform velocity. Moves with the uniform velocity. I hope you will be better clear regarding this segment, and you will understand more clearly regarding the 6 segment of different segments of the graph. First one is a straight line, and it is a slanting line. Parabola is upward, parabola is downward. Since it is decreasing and comes back to 0, and it is crossing beyond to the B, that is reaches to C. I hope you will be very clear. Don't forget to like, subscribe the channel. Thank you very much, and don't forget to comment also. Thank you. Thanks a lot.